Good morning, students. Today, myself, Pradeep sir, discuss the irrational numbers for ninth class students. The first topic is what is irrational number? A number which can neither be expressed as a terminating decimal nor as a repeating decimal. This is called an irrational number. That means the non-terminating, non-repeating decimals are irrational. Here, some examples are given. In 0.01, 001, 0001, 00001, and so on. Clearly, this number 0.01, 001, 0001, 0001, and so on is a non-terminating and non-repeating decimal, and therefore it is said to be an irrational. Similarly, 0.02, 002, 003, 00003 is irrational. All these number patterns are irrational. The second example, suppose m is any positive integer which is not a perfect square, then root over m is irrational. The meaning of perfect square means root under 4 that is equal to 2, root under 9 that is equal to 3. These numbers are the perfect square numbers. Here remember that if m is a positive integer which is not a perfect square, then root m is irrational. Example, root 2, root 3, root 5, root 6, root 7, root 8, root 10, root 11 are the irrational numbers. Clear? Type 3 of irrational numbers. If m is a positive integer which is not a perfect cube, then cube root of m is irrational. That is called 2 to the power 3, 2 to the power 3 into 1 by 3 equal to 2. It is a perfect Q number, so cube root 8 is a perfect Q number. Clear? So m is a positive integer which is not a perfect cube, then cube root of m is irrational. Thus cube root of 2, cube root of 3, cube root of 4, cube root of 5, cube root of 6, cube root of 7, cube root of 9, 8. Here 8 is the misprint. Cube root of 9, etc. are the all are the irrational number. Clear? Some of the special irrational numbers like pi. We consider pi equal to 22 by 7. Pi equal to 22 by 7. 22 by 7 is a rational number. But always remember that pi, it is a ratio between the circumferences of the circle by the diameter of the circle is always constant, that is called the pi. This pi is an irrational number. Clear? Properties of irrational numbers. Irrational numbers satisfy the commutative, associative, and distributive law for the addition and multiplication. These rules you have already studied in earlier classes. So must be remember that irrational numbers satisfy the commutative, associative, and distributive law for the addition and multiplication. Clear? Rule number 2. Sum of the two irrational numbers need not be an irrational. Either it is irrational or the sum is irrational. In the first example, 2 plus root 3 and 4 minus root 3. Sum of 2 plus root 3 plus 4 minus root 3. Here again misprint 2 plus root 3 and 4 plus root 3, that is 4 plus 2 equal to 6 plus root 3 2 root 3. This is an irrational number. Clear? But 2 plus root 3 plus it is irrational and irrational. Also 4 minus root 3, it is also irrational. The sum of the two irrational numbers may be irrational. Root 3 cancel and your result is 2 plus 4, that is equal to 6, and 6 is a rational number. Clear? The next rule, always you must be remember that difference of the two rational number need not be an irrational. Either the result is rational or irrational. Suppose two rational numbers 5 plus root 3 minus 3 plus root 3. 5 plus root 2 minus 3 minus root 2. Root 2 subtraction that cancels and the answer is 2. In this case, the difference of the two irrational numbers be rational. The next example, 5 plus root 2 5 plus root 2 minus 5 minus root 2. Thus 5 plus root 2 minus 5 plus root 2. 5 cancels. The answer is 2 root 2. The answer 2 root 2 is an irrational number. So difference of the two irrational need not be an irrational. It is either rational or irrational. Product of two irrationals need not be an irrational. Similarly, root 3 is an irrational number. Root 3 into root 3, that is equal to 3, which is a rational number. In this question, root 3 plus into root 5, irrational. The product of two irrational number, that is equal to root over 15. Now root over 15 is an irrational number. So the product of two irrational numbers either be rational or be irrational. Quotient of two irrationals need not be an irrational. In the first case, 2 root 3 divide root 3. Irrational divided by the irrational. Root 3 cancel. The result is 2. It is a rational number. Again, root 6 divided by root 3. An irrational gives the result root 2. It is also irrational. So you understood that a quotient of two irrational need not be an irrational. It may be rational or it may be an irrational. Some other important result: sum of the rational and irrational is irrational. Sum of rational and irrational is irrational. It is any irrational number, suppose 2, any irrational 3, the sum of these two numbers always be irrational. Difference of rational and irrational is irrational. Rational 2 is the rational number and minus root 3 is an irrational number. The difference between these two always be irrational. Product of rational and irrational is irrational. 2 is the rational number and root 3 is the irrational number. The product of these two to root 3 always be irrational. Quotient of rational and irrational is irrational. 2 divide root 3 equal to 2 by root 3 always be an irrational number. An important result: if A and B are the two distinct positive rational numbers, then the mean of the A and B, that means A plus B divided by 2, is a rational number lying between A and B. Suppose if A equal to 2 and B equal to 4, the 2 plus 4 by 2, 6 by 2, that is equal to 3. 3 is lying between 2 and 4. Clear? The second result, root over AB is an irrational number lying between AB. A equal to 2, B equal to 4. So root over AB, that means root under 8, is an irrational number lying between A and B. You find it by the division method. How can we find the value of root 8? 8 2 2 ja 4, subtract 4, decimal, to here to sum, 2 to 4, put double zero. So give that the whole number is 2, then other number is the decimals number. Clearly 2 points number is greater than the number is C. So 2 is greater than 2 point something is less than 4. So we can say that root over, we can say that A is less than root over AB is less than B. So AB is an irrational number. These are the some examples. Are the square root of all positive integers irrational? If no, give 2 examples. The square root of all the positive integers is not always be irrational, because root over 4 equal to 2, 2 is a rational number. Root over 9 equal to 3, 3 is a rational number. Root over 16 equal to 4, 4 is a rational number. So we can say that the square root of every positive integer is not always be irrational. Clear? Are the cube root of all positive integers irrational? If no, give 2 examples. The cube root of 8 equal to 2, 2 is a rational number. Cube root of 27, that is equal to 3, this is not irrational, it is a rational number. Similarly, cube root of 64 equal to 4, 4 is a rational number. So we can say that the cube root of a positive integer is not always be irrational. Write 3 numbers whose decimal expenses are non-terminating and non-lifting. We know that if m is a positive integer, which is not a perfect square, then root over m is an irrational number. So root 2, root 3, root 5, root 6, root 7, root 8, these are the irrational numbers. We know that the decimal expansion of irrational numbers is non-terminating and the non-lifting. So root 2, root 3, root 5 are the examples of irrational number. Insert a rational number and an irrational number between 3 and 4. Earlier we have discussed rational number 3 plus 4 by 2, that is equal to 7 by 2. 7 by 2 is an irrational number. A rational number root over 3 into 4, that is root over 12. Root over 12 is an irrational number between the 3 and 4. Find 2 rational numbers So you have find the many irrational numbers, infinite irrational numbers between any given two numbers. By this, first you divide 1 by 7 and get the result. Again you divide the second number and get the result. Then you insert any number which is greater than the value of 1 by 7 but less than the value of 2 by 7. Clearly? So here we insert the two numbers. So clearly you see that 0 0.0, 0 0.160, 1600, 16000, 1640, and so on. It is a series of the non-terminating and non-repeating decimals. Similarly, 21, 211, 2 111, 2 1, and so on. So you see that these two numbers are between 1 by 7 and 2 by 7. By this way, you will find the infinite number of irrational number. Find the two rational and the two irrational numbers between root 2 and root 3 by the division method. First, to find the value of root 2 and root 3. And similarly, in the previous question, we find the two numbers between the root 2 and the root 3. Clear? If 1.5 and 1.6 is a terminating decimal, so it is a rational number, and this value is non-terminating and non-repeating, so it is irrational numbers. So by this way we can insert many irrational and irrational numbers between given numbers. So students, in this chapter we have do all these kinds of questions. I think you have now able to do these kinds of questions, all these kinds of questions. If you have any problem, you must be ask me on my WhatsApp number. My WhatsApp number 99399288255 by Pradeep sir. Thank you watching my video. If you like, then must be press the like button. If still you have not subscribed my channel, please subscribe and press the bell icon for my latest video. Thank you again.